Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello friends, in today's video we will be learning how to manage the cluster of containers. So first of all, we will discuss about different cluster management tools. So what is a cluster management tool? It is a software program that helps you manage a group of clusters through a graphical user interface or by accessing a command line. So a management tool is used to configure the clusters or manage the clusters, and these management tools provide you a user interface or a panel through which you can manage those clusters. Also, you can use the command line presented by the management tool. Now, with these tools, we can monitor nodes in the cluster, we can configure the services, and also we can administer the entire cluster server. So once we are using a tool, we don't need to worry about the cluster management because it is all taken care of by that tool. And also the cluster management can vary from low involvement activities such as sending work to a cluster to a high involvement work such as load balancing and availability. So it totally depends upon the management tool which you are using for managing the cluster. Now first of all we will discuss about Docker Swarm. So Docker Swarms let you cluster a number of Docker engine into one virtual engine. So it basically means that if you have a different set of clusters or nodes, you can simply use Docker Swarm to compile them into a single Docker engine. And the benefit of that is that you can simply manage your all the cluster and nodes from a single panel. Now in a distributed application environment, as the compute elements must also be distributed. So Swarms allows you to cluster Docker engines natively. So by here natively, basically we are saying that Docker Swarm was basically created by Docker itself. So it has all the inherited properties of Docker, and you don't need any further dependency or third-party tool to manage the Docker clusters through Docker Swarm. Also, one of the advantages it has is that it is a native solution. So whether you want to implement Docker networking plugins or volume, you can simply do that using the Docker Swarm. Now here is the basic infrastructure of Docker Swarm. Here we have the compose part, and here we have the swarm and cluster managers. So once we write the YAML description file, we can execute it using the Docker CLI, which is basically the Docker command line. And after executing the commands, you can manage all these clusters present using the Docker Swarm. So Docker Swarm is basically the management of these clusters at a certain level. Now, once these clusters are placed in a Docker engine, you can create one Docker engine or two Docker engines. After that, you can use cluster managers to separate them into different entities, or you can also use different type of cluster managers for managing these Swarm Docker engines. So basically the Swarm engine is having all the properties of Docker Swarm, which is in turn helping in managing the clusters. Now the second type of cluster management tool is Fleet, which is the Core OS. Now Core OS was created to allow you to scale and manage compute capacity. So the fundamental principle behind introduction of Core OS was to manage the compute capacity, which is the resources which a container is using. So in case if you are concerned about the resources being used by the container, Core OS can be used to manage the configuration. Also, rather than installing a package through Aptorium, Core OS leverages Linux containers to handle services at higher abstraction level. So basically it is helping us in installing all the dependencies related to the containers and our programs which we are using, and provides advantages similar to virtual machines, but with the concentration on application rather than complete virtualized host. So the main focus of Core OS is to give more importance to the clusters and the containers which you are using rather than the virtualized host. So you can leave all the configurations of your server, whichever server you are using for hosting the containers, and the core OS will take care of all those configuration and manage them accordingly so that you are using the sufficient amount of server resources. Also, it allows you to conceptualize a core OS cluster in a scenario where it shares an individual init system. So if you are sharing a single init system, you can conceptualize a core cluster, or you can simply create a core cluster where you can run all your containers. Talking about the infrastructure of CoreOS, so once you are integrating CoreOS with Docker, we have a thing called Fleet. So Fleet is basically the set of different CoreOS hosts which you have created, and you can install Docker in it. And after that, once the Docker containers are placed on the CoreOS host, you can simply manage their resources using the Fleet. So the Fleet is acting as a configuration manager of these core OS hosts. So, and you can also create a single host, or you can create a multiple host. Now the third cluster management tool, which is a very famous tool, is Kubernetes, and it was designed by Google. So developed by Google, Kubernetes allows you to manage containerized application across many different hosts. So once you have a containerized application present on different type of hosts, then the Google Kubernetes can be used effectively to deploy, scale, and maintain the applications at a very efficient level. Now it is, as it was developed by Google, so it has the ability to repair itself on the fly, and also has features like auto replication, auto restart, and auto placement. So auto replication helps you to replicate the number of containers on the fly, and you don't need to create and deploy a single container again and again. You can simply auto replicate them, and if the container is stopped due to certain reasons, it can also auto restart the containers, and it can also place the containers accordingly to the needs of the user. So you don't have to worry about placing them from one host to another host. It can manage it by itself. Also, it is endlessly extensible, and it was built to be hookable, pluggable, and modular. So from endlessly extensible, we are saying that Kubernetes can be extended to 1,000 services resources which you can use, and it can be extended up to a number which you can think of. So you can deploy as many applications as you want using the Kubernetes engine, and it won't face any difficulty in doing that. So hookable basically means that you are able to integrate your Kubernetes engine with multiple hosts and application, and you are not facing any integration issues. Pluggable and modular means that you can manage the Kubernetes engine according to your needs. So you don't have to go through the guidelines of Kubernetes only. You can also implement your own set of configurations on the Kubernetes engine. Now, the basic fundamental principle of Kubernetes is that it uses pods that acts as a group of containers and are scheduled and deployed at the same time. So you are creating a pod which is having a group of containers, and it is carrying a number of containers, and you can manage those pods by scheduling and deploying them. A pod could be a single container, or it could be a multiple container environment. Talking about the infrastructure of Kubernetes, here we have a Google Cloud Shell. So Google Cloud Shell is the command line presented by the Google Cloud Platform, which you can use not only for the Kubernetes engine, for you can also use it for multiple GCP services. Now here you will get a kubectl. So kubectl is the basic command line for Kubernetes engine. So once you are using the kubectl, you can manage the Kubernetes cluster. So here inside the cluster, you can have different containers. And let's say if you have a container registry, which is a Google container registry, so you can use the Docker file to create a image, and you can use the command line to fetch the image. So by doing that, you are simply able to manage these clusters using the Kubernetes engine and simple commands. So these three management tools are the famous management tools which you can use to manage your containers without any hassle. And that was all for today's video. Thank you.